Hello, everybody. This is Michael Smith from Rising Tide Cybersecurity Management. And today I'm going to be talking about some of the DDoS mitigation technologies, the big six, as I like to call them, what they're good for, how to use them, how to deploy them, and then an overall strategy on how and where to use particular ones. So this is me. I'm an independent consultant. I do a lot of consulting on issues like DDoS management, web and infrastructure reliability, threat intelligence, just about anything that I've done in some of my past positions. I think relevant to our discussion today, I was the CSIRT director for Akamai from 2012 to 2015, and I fought some of the biggest DDoS campaigns as part of Operation Ababo. But I've been studying DDoS since about 2008, when I started seeing some of the early hacktivist campaigns against the Church of Scientology and some of the other organizations. I was the incident manager during Operation Avenge Assange, so I was on the receiving end of some hacktivist attacks, and then my time working with Akamai CSIRT. Ironically enough, I used to talk customers through all of the different options that we're talking about today. And I used to make a joke of it that if I ever became an independent consultant, I would help people to understand all of these different options and technologies. And today, here I am. Now, this one isn't rocket science, but the first thing that people do when they start looking at mitigating DDoS is they start to over-provision. And by that, what I mean is network operators used to run their networks at about 80% usage. And so now they're looking at 60% usage or 40% usage. It's not a well-known fact, but most of the DDoSes that are out there are relatively small. So they're 1 gigabit per second in size or smaller. And so it actually does pay when there's a cycle of DDoS attacks. It does pay for you as an organization to start to beef up your hosting. So your web hosting, your email hosting, your network connections. There's a bunch of different technologies that are in line, starting from the back databases to web servers to application servers to firewalls to network switching to router capacity to the number of circuits that you have from ISPs or from multiple ISPs. And DDoS comes in sort of this cycle where you won't hear about DDoS attacks for 3 years. And then suddenly for 2 years, that's all anybody can talk about. And so during one of those cycles, it actually is a good idea to start having more capacity than you think you need. One of the side notes for this is you could transfer a lot of that to cloud services. Use one of the hyperscalers, so Amazon, Azure, Google Cloud Platform. Use some of the inherent capabilities that they have. So they have some traffic scrubbers, but just being able to stand up a lot of servers very rapidly is a benefit in this kind of model. Now, the downside to this is that because you're over provisioning, you might end up paying a lot more than you normally would otherwise in a world without DDoS, because normally you do capacity scaling for your operational load plus a little bit extra, so that's usually around 20%, to accommodate spikes in traffic. But now, because you're using a cloud service or you're buying servers or you're buying circuits, now you incur a lot more costs than you normally would for that same amount of user population. One thing that you really have to look at when you start looking at over-provisioning things is your authoritative DNS or wherever you host your zones. That is very, very important because, as you know, if DNS dies, then it doesn't actually point to any of the services that you have. So if you have a restriction or a bottleneck on the number of servers you have because you're hosting them inside of hosting them on premises, or you're using a service provider that only has 2 small servers as part of their infrastructure, that actually becomes a point of failure when you're looking at defending yourself from a DDoS. So it's very much in your interest, if you're worried about DDoS attacks, to go and go use service providers and use multiple service providers for your authoritative DNS in order to diversify your authoritative DNS across different services. So like I said before, 60% is the new 80%, especially during that peak cycle of DDoS attacks. A lot of times you have equipment that has an organic DDoS mitigation capability, right? So you might have IDS that, oh yeah, it also understands some DDoS attacks, and you can use that IDS just to start dropping the traffic. Maybe your routers have the ability to do static IP ACLs, and maybe that will work for a small attack where you just blacklist the sources because there's a limited amount of sources, and you can start dropping that traffic. Maybe your load balancers, so if they're say F5 load balancers, you've got iRules and you can implement iRules for some type of traffic. Or you could even run some software on your application servers that would detect a DDoS attack and go ahead and drop that traffic. It's not foolproof because you're limited by the amount of bandwidth that you have from the ISPs. You're limited by the capacity in both in bytes and in number of packets per second and in number of sessions. So like TCP sessions that are open on your routers, your switches, your firewalls, your application servers. And so you have to kind of understand that and scale appropriately. Right? But once again, keeping in mind that this isn't a catch-all, this is just more along the lines of a best practice for scaling out your hosting infrastructure. The second mitigation technique is anti-DDoS appliances. Now, typically these are, sometimes they're IDS that understands DDoS patterns. A lot of times they're kit from Arbor, which is now Forescout, or Radware, or maybe Carrero. I think they do something like that. But really, they're overly simplified. They're IDS machines that have a lot of capacity that understand DDoS traffic. Now, you use them for a couple things. The first is that they're really, really good at monitoring, especially in conjunction with other mitigation technologies. So that way you can see how much traffic is not getting mitigated that should, and they can signal upstream. But they also have a capacity to drop DDoS traffic, and you can do it inside of your own infrastructure. So either you put it upstream of your firewalls or you put it upstream of your routers. There are a couple different ways. It depends on the technology. But they do just simple rate accounting. They count the number of packets, the number of bytes, the number of TCP sessions, the number of HTTP requests if they can. And when they detect some kind of a DDoS pattern or just a load of requests, they start dropping requests of that type. What you'll see for organizations that have a large hosting infrastructure is that they've started building their own scrubbing center out of these appliances just because, they might have 100 gigabits per second of capacity because they're a large multinational bank. They get a lot of attacks. It's actually the right kind of cost equation for them to buy appliances and to build their own scrubbing center out of them. I mentioned this before, but really the best use for appliances is going to be that monitoring. And there becomes an issue in monitoring where you really want your to be able to inspect traffic that's inside of TLS or SSL. And so you run kind of this problem where do you want to provide TLS keys to a service provider, have them break apart your TLS traffic, inspect the HTTP inside of that TLS for badness, and then drop it. And so a lot of companies, instead of providing their keys or doing some kind of a key exchange or just using keys on the service provider, they will go and build their own mitigation scrubber and use a couple different techniques to be able to actually inspect that traffic. And so there's a really good use there for the appliances to be able to do that. I think there's also a piece where appliances come in where if you say you use a scrubber at the ISP, and we'll talk about that, or a third-party scrubber, or a CDN or something like that, you can you still need to be able to monitor the traffic that's coming into your network to see what's getting past mitigation and to be able to actually either move that new attack to mitigation or signal upstream to the scrubbing center that you have a large amount of traffic that's making it through the scrubbing center. One of the limitations of anti-DDoS appliances is that you're still limited by the amount of bandwidth that you have coming from your ISPs, right? So if you have, maybe you have 20 gigabits per second, which is pretty good for a small or a medium-sized business, but maybe the multinationals will get up to 100 or 120. But you can't have more capacity and mitigation than you have bandwidth, because the bandwidth will get saturated and it'll cause an availability problem before that traffic makes it to mitigation. So it's like broadening the highway where you have, or broadening your driveway where you have a 6-lane driveway, but all of that traffic still has to make it in the highway, and that's where the actual traffic jam is. Then the next type of mitigation is going to be your scrubbing center. Now, most ISPs, actually all of them, I'd be very surprised to find an ISP that doesn't have a scrubbing center, but they all have a scrubbing center. And the way that the scrubbing center works is that ISPs have their own peering where they connect to the other ISPs. And as that traffic comes in, they can route a customer or an individual IP address through that scrubber. They have the same appliances that you would put on premises. They've got appliances there, but they have a lot more capacity. They clean up the traffic and then dump that clean traffic into the core of their network where they can deliver it to that hosting environment. Now, just like appliances put inside of your data center, the scrubbers at the ISP also have this capacity problem. Well, it's not a problem, it's just a concern, where the ISP has a certain amount of bandwidth that they use to connect to the other ISPs. And so they'll only have scrubbing capacity compared to their amount of bandwidth that they have where they connect to other ISPs. And so if that capacity gets more than the amount of bandwidth that they have with the other ISPs, then they will actually have to black hole the traffic or shunt it to a bigger scrubber. And we'll talk about that in just a little bit. I think one of the big advantages with using the ISP or carrier scrubbers is that a lot of times they'll have an MSSP or a security service. So they will have folks who are trained to operate the equipment, and the fact that they can route individual IP addresses or network blocks. I think that gives the ISP a lot more flexibility. I think one of the downsides to that is most people that are running large hosting centers are buying bandwidth from multiple ISPs. And so if one ISP allows a lot of extra attack traffic through, that causes an outage, even though the other ISP or the other ISPs are there doing their job with their scrubbing center. The ISPs normally, unless you pay them and they have a special setup to do that, most of them don't do monitoring of your network usage. And so you have to do a lot of that monitoring yourself, which leads us towards some of the on-premises appliances. The on-premises appliances are made to work with the ISP carriers. A lot of time that those devices are made by the same manufacturer. Or they might even be the same devices, just in different usage. Or they're made to work with third-party scrubbing services, and so they can monitor and actually be used on premises to route traffic through the scrubbers, both the ISP scrubber and the third-party scrubber, and they're also used to signal to the bigger scrubbers what kind of attack traffic is coming through that they need to now clean. And that leads us to the third-party scrubber. So the third-party scrubbers have deployments out usually close to some of the internet exchanges, and they buy bandwidth from multiple ISPs. The way that you route your traffic to them is usually through BGP. I think a side deployment or a side technique that they sometimes use is where the scrubber has a set of IP addresses and you use DNS to direct individual host names to the scrubber, and then they have a DNS entry that they use to return traffic to you. But normally you use BGP to get the traffic to the front of the scrubber. On the back of the scrubber, they'll use something like a GRE tunnel or a fiber cross connect, or maybe you could even use SDN, MPLS. There are a couple different ways that they use to get that traffic back into your data center, and then your traffic back to the endpoint goes directly out using your normal routing, your normal network connection. There are only a handful of third-party scrubbers that are out there. Akamai and Prolexic. So Prolexic is owned by Akamai. They're one of the biggest ones. Newstar / Arbor Cloud is another one. There are some others that are out there. So Radware, Carrero, Imperva has Incapsula, which is their cloud service. They have a scrubbing service called Behemoth. F5 has a service called Silverline that's DNS based. But the two big ones are Akamai and Newstar, and then the others are smaller in capacity, smaller in points of presence. The primary reason why you'd use a third-party scrubber is just because of capacity, right? So usually they're in between 3 and 10 terabits per second. I would be really surprised if the two big ones don't have more than that at this point. Really, they look at scale. They look at the average size of attack. They look at the historical maximum size of attack, and then they do calculations to be able to support three or four or more simultaneous attacks, plus live customer traffic, non-attack traffic that's coming through their platform. So they try to scale out for that. That's really the big reason why you would use the cloud scrubbers. Sometimes they're used in conjunction with the ISPs. So Arbor, who makes the appliances for on-premises, they make the appliances for the ISP scrubbers. They make appliances for some cloud scrubbers. And all of those are designed to work in conjunction with each other. So you try to deal with it at the smaller level on premises. If the capacity is bigger than capacity you have, then you shunt traffic to the ISP. If it's bigger than the traffic at the ISP, you get shunted to the Arbor mitigation cloud, which it's actually Newstar. It's all white labeled. One of the downsides is that your traffic now has to get routed to a limited amount of scrubbing centers. So you do incur some latency, especially inside of Eastern Europe, Africa, Middle East, and East Asia. The folks who run the big scrubbing centers, they're working on ways, additional deployments, additional traffic management methods to give themselves more POPs and to minimize that amount of latency. And that brings us to the Cloud WAF, or Web Application Firewall, and Content Delivery Network. Now, the way that they work is that they function as a very distributed reverse web proxy. So they put up points of presence all around the world. You use DNS to get your traffic to their service. They only listen to HTTP, HTTPS. They will run rate accounting, so they'll count the number of HTTP requests and cut off source IP addresses when they get too greedy. They will also drop non-web traffic. Then they will use a DNS entry that tells them where the infrastructure is, where the hosting, the application hosting or web server hosting is, and they will forward that traffic there. Now, The good thing about this is that the CDNs and Cloud WAFs, right, and I'll group them together, they have a lot of capacity, right? They have a way more capacity even than the cloud scrubbers. And so they can drop a lot of traffic, and they can also deliver a lot of traffic. One of the downsides is that since they only deliver a web, so HTTP, HTTPS traffic, they can't deliver anything that's not that. So you'll see things like gaming traffic, which is all UDP, SMTP traffic, so email, web traffic on non-standard ports. They can't deliver that. Now, granted, the majority of targets for DDoS are going to be web applications, web servers, and APIs. And then there's one subset of DDoS attacks that targets things that are not web, that are inside of the hosting infrastructure. So where the CDN uses a DNS entry to determine where it should forward traffic to, that's the authoritative web servers. If the attacker knows that network block for the authoritative web servers, they can flood it with traffic and bypass the CDN. So in the CDN world, we call that a direct-to-origin attack. And it happens. It happens maybe 10% of the time, 15% of the time, if that much. And so the CDNs and Cloud WAFs have figured out a series of mechanisms to block that traffic. The simplest one is they give you a list of IP addresses for their servers, and you block out all traffic, hopefully at your ISP, but failing that, you can do it on your own infrastructure. So you block out all traffic for your web servers that doesn't come from the CDN. Another way is to use some kind of SDN or GRE tunnel or some other kind of routing. You could even do a fiber cross connect inside the ISP. You could do MPLS. You could do a bunch of other different techniques to get that traffic from the back of the CDN into your infrastructure. I think hands down the biggest benefit for using a CDN and Cloud WAF is that they also can cache and deliver objects. They can run applications, all of them, at least the modern ones today. They can do a lot more things other than just DDoS mitigation. And so that gives them a definite value beyond maybe DDoSes that you prepare for and spend a lot of money on mitigation and you don't get any attacks. And so I think they're definitely worth considering. If you are you have a website that gets a lot of traffic, then definitely go on the CDN and WAF side in conjunction with other technologies, and I'll talk about which one's best here in a minute. But definitely they do have a lot of benefits aside from DDoS mitigation. As far as vendors in this space, there are the three big ones. So Akamai, Cloudflare, Fastly. They're pretty much the three dominant CDNs that have Cloud WAF. There are some upstarts there. So ThreatX is a good one. I worked with PolarisSec in Southeast Asia. They've got something. There are a couple other people building similar services that are out there. Out of the three hyperscalers, Amazon has their Cloud CDN. They call it CloudFront. They've got a web application firewall. They're a little bit harder to set up than the big three CDNs. Google Cloud Platform has their own CDN, and they do some kind of mitigation for their own platform. Azure works in combination with some of the CDN and WAFs. And lastly, there are a handful of companies that are out there. F5 has Silverline, which has evolved over time, but they've got a CDN and WAF there. Imperva has Incapsula, which is their cloud-based offering, and it's a WAF and CDN. There are a couple of regional players that I know of, but they're mostly small. And that brings us to the last mechanism, which is remotely triggered black hole, or RTBH. And believe it or not, this is the most commonly used technique to mitigate DDoS. it's not really what I would call mitigation. It just makes the traffic go away. And what happens is every ISP around the world sets up the RFC 1918 address space. So 192.168.x.x or 10.x.x.x. And there's 127.x.x. And they set those up to be routed to the null interface on their routers. So if I take a network block and say that the way to get to that network block is now through an RFC 1918 address space, all of the routers around the world will start dropping traffic that's intended for that destination. Now, I say it's not really mitigation because it also kills legitimate traffic. So legitimate traffic doesn't get to you. You basically just give up and say, "Hey, drop all my traffic. I'm going to take the outage, take the availability problem, but I also don't get all that attack traffic coming back to me." Now, you'll see black holing used a lot with smaller sites, sites that are of no real importance. And the reason why is because those sites themselves don't make any money, right? Or they make a small amount of money. And the cost to actually buy all the bandwidth, buy all the servers, buy the scrubbing service, buy CDN, all the cost for all of that is just higher than the actual income that the site owners get out of that site. So at some point you just say, "Hey, you know what? We're just going to take the outage because until the bad guys go away, because it's just not cost effective for us to defend against that attack." You'll also see this happen a lot where the carrier or the ISP, where their scrubber gets overloaded, and the carrier will do exactly the same thing, and they'll say, "Look, in order to protect my own peering with other ISPs, I have to black hole that traffic just to reduce the amount of traffic that's coming across my peering." And so they'll do that, and at that point, the ISP customer just has no choice in the matter because the ISP has to protect their other customers from that customer that's getting attacked. And that brings us to our final question, which is, which one of these methods is best? And I've seen this a lot in this space. I've been studying DDoS since 2008. I've worked for a service provider since 2010. I see this all the time, which is people that are looking to defend their infrastructure from DDoS. Really, they're looking for the best method. And honestly, the answer is none of the methods are best. They all have positives. They all have things that they're really, really, really good at. They also have things that they're really, really bad at. And so the smart people that are out there that are getting lots of attacks, they are using two or more of these different technologies in layers, and they have some kind of a rule set or business logic or gating criteria for when do they use one technique or technology versus when do they use another. So for instance, it's very common to see people use a CDN and Cloud WAF and a third-party DDoS scrubber. Right. In fact, there's one vendor out there, and that's Akamai. They own both. In fact, I think Neustar has a CDN/WAF, and they have a mitigation scrubber. I've also seen people who use on-premises appliances, and they use a scrubbing center from the ISP when they get over capacity, and then the ISP gives them the opportunity to move to the Arbor Cloud Scrubber if the attack is of a size that's larger than the ISP can take. So that's two and maybe a third scrubbing technology. I've also seen a lot of people go and use the hyperscalers, so use the infrastructure as a service provider, cloud provider, and scale up their infrastructure there to a point, right? And to a certain amount of servers or a certain amount of traffic. And then at that point, switch over to maybe mitigation provided by the cloud provider, right? Or they'll use the cloud provider, scale up their infrastructure a little bit more than they need, and then use Cloud WAF and CDN in front of that, right? Most folks are quite literally going to use 2 or more different methods. This also implies that you need some kind of a playbook, and you need to rehearse that playbook. I think DDoS is an interesting space because of the cyclical nature that it has, where by the time a new wave of DDoS attacks comes around, everybody's forgotten how to fight it. All of their technology is out of date. Maybe they didn't renew their contracts from service providers because they didn't use the technology last year. So they've dropped their contract, and now suddenly a new wave of DDoS attacks come, and they have to relearn all the lessons that they knew 3 years ago. So I think there's a huge amount of value in being able to turn on mitigation, test that it works, test that your operators know how to use it, test your own command and control or your communications plan, and then be able to off-ramp off mitigation, however you use mitigation, and go back to your normal state of operation. I also think there's a lot of value in understanding how to launch your own attacks, or to have service providers in the audit and assessment space who know how to do that, so that way you can actually test that your mitigation can detect and mitigate attacks that you send to it. Unfortunately, there's no good way to learn how to do attacks like that out across the internet, because it's damaging to the fabric of the internet. In fact, if you look at the code of conduct for CISSP and several other certifications, you don't do DDoS testing across the internet. So you have to be really, really careful with it. But I do think there is a place for limited scale, limited scope DDoS testing, simply because you don't use your mitigation technology as much as you do other types of security technology. And as a reminder, I am an independent consultant. I talk to a lot of people about DDoS mitigation, web survivability, DNS, internet infrastructure, along with some other things. I touch on IoT security occasionally, just security management for startups. I advise some cybersecurity startups as a free-range CTO. If you need to get a hold of me, just drop me a message on LinkedIn. You can go to my site. The URL is there. And thank you for watching this, and have a nice day.